Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello and welcome to the session on linear regression using Python. In this session, we would like to learn about the different assumptions which needs to be made before we try to run a linear regression. In other words, there are certain conditions that has to be met before we run a linear regression. Let's try to understand them. The first condition before we make a linear regression is the relationship between the variables should be a linear. For example, we always know the dependent variable is plotted in the y-axis and the independent in the x-axis. So we need to make sure the relationship between the x-axis and the y-axis, the dependent and the independent, must be a linear, which means I should be able to draw a straight line. It should be either constantly increasing or constantly decreasing. It should not be a pattern which is wavy. It should not be a pattern which is erratic. It should not be a pattern which is evenly spread across the graph. It should be a linear, which should be increasing steadily. In other words, if it does not follow a linear regression, then if it does not follow a linear pattern, then we do not choose linear regression as the best model. We might have to choose some other model. Right? So that's the first assumption. The second assumption which a linear regression makes is the trend of the future will be similar to the trend of the past. So that's an important assumption. When we have to make sure the trend of the future will not be any different from how it behaved in the past. For example, after the increase in the coronavirus cases, we cannot expect a company to perform the way it was performing before the coronavirus cases. So that will be a special exception. I just cannot run any kind of a model which I had built before this and expect it to work properly. I need to have different models which could be reading the data of a similar situation. So that's an important assumption. We need to make sure the trend of the future will be similar to the trend of the past, right? So now the third assumption is about the linear regression works best in the case of interpolation. What do we mean by interpolation? If we notice here in the picture below, we have certain points, the independent variable in the x-axis, dependent on the y-axis. Now, we can see the maximum extent to which the points lie is the b, and a is the starting point. So in this case, we can predict any value between a to b in a very good fashion, but not necessarily if we try to predict the values outside b, it might not work well because it might not be the same trend throughout. There might be a decrease in the trend, there might be a certain increase in the trend, or there might be a steady increase after this point. So we need to ensure that it has to go the same way as it had been going all this while, or else we need to make sure we do not make any kind of prediction beyond the extent which we had trained the data. So this is called interpolation, which means it remains within the boundaries, and extrapolation, which is beyond the boundaries. So this particular value might not be a good prediction. It might be, might not be, but I cannot be sure about that. But the value over here, that can be a good prediction because it lies well within the boundaries. The last assumption which linear regression makes is about the collinearity. We need to ensure that there is no collinearity between the variables, which means variables are not dependent on each other based on which we are predicting. For example, the amount of sweet intake I take increases the chances of me getting a diabetes, which means they are directly correlated to each other. They have a high collinearity, which means one increases, the other increases, and the one decreases, the other decreases. There could be negative collinearity between variables. For example, in similar case, if the higher is the care I take of my body, the lower are the chances of me falling sick, which means the one variable goes high, the other variable goes low. The one variable goes low, the other one goes high. This is a classic example of the negative collinearity between two variables. This is the last assumption which a linear regression makes, and once we are sure about these four variables, these four factors, we should be good to make any predictions in linear regression. That was about the assumptions for linear regression. Thank you.